Hi, and welcome to Parabolas Day 4. And the big question today is, are all parabolas similar? We showed yesterday and the day before that some parabolas were congruent, not all parabolas were congruent. And in order for a parabola to be congruent, the distance between the focus and the directrix had to be the same. So write equations for two parabolas that are congruent to the parabola given by y equals x squared and explain how you determined your equations. So if I can say y equals x squared plus 1 and y equals x squared minus 1. And I know that they are congruent because the coefficients of the x squared term are the same. Therefore, they are congruent. Sketch the graph of y equals x squared and the two parabolas you created on the same coordinate axes. Well, y equals x squared looks like this. And if I were to do x squared plus 1, I'm just going to move my vertex up 1. So y equals x. So y equals x squared plus 1 is there. And this is y equals x squared minus 1. Write the equation of two parabolas that are not congruent to y equals x squared. Explain how you determined your equations. Well, y equals 2x squared and y equals 1/2 x squared. And here, the coefficients are not congruent, or not the same. I'll say not the same. Therefore, they are not congruent. So sketch the graph of y equals x squared and the two non-congruent parabolas you created on the same coordinate axes. So this is y, this is x, y equals x squared is here. And then this is y equals 2. Hang on. So y equals 2x squared. And this is y equals 1/2 x squared. What does it mean for two triangles to be similar? And how do we use geometric transformations to determine if two triangles are similar? So, in order to know if they were similar, the angle measures were the same. But the sides were proportional. And how do we use geometric transformations to determine If two triangles are similar, we used dilations. So two figures are similar if a sequence of transformations would take one figure onto the other one. So what would it mean for two parabolas to be similar? How could we use geometric transformations to determine if two parabolas were similar? Well, then we would be able to use a dilation to show that they were similar, which is a non-rigid transformation. So for them to be similar, we'd have to apply a dilation which is a non-rigid transformation. So use your work in exercises 1 through 6 to make a conjecture. Are all parabolas similar? You answer. All right, the parabola at the right is the graph of which equation? Well, we have our focus labeled, we have our directrix labeled. It says for part A, label a point x, y on the graph P. It can be any point. I'm just going to pick any point on the graph and label it x, y. And what does the definition of parabolas tell us about the distance between the point x, y and the directrix here, and the distance between the point x, y and the focus here? It says they must be congruent. So create an equation that relates these two distances. Well, normally we talk about the y distance being my vertical distance, but I don't have a vertical distance today, but I do have a horizontal distance. So I can count that as x. Oh, sorry, from here to here is x plus 2, because this distance from here to here is 2, and this distance from there to there is x, so the whole distance is x plus 2. So we have x plus 2 has to be equal to the distance formula of x minus 2 the quantity squared plus y minus 0 the quantity squared, because this is the point to 0 for my focus. And then D says solve this equation for x, so I'm just going to go right from here and solve it. First thing I need to do is square both sides, get rid of the radical, and that means that I will have x squared plus 4x plus 4. Do the box method off to the side if you don't see that. Here I will have x squared minus 4x plus 4 plus y squared. As I look at this, I know my x squareds are going to cancel out, and I also know that my 4's are going to cancel out. But I can subtract my 4x from both sides, and I will get, add 4x to both sides, my bad. 8x equals y squared. Divide by 8, x equals 1/8 y squared. Find 2 points on the parabola P, show that they satisfy the equation found in part D. So if I go back up to the graphs, I can see that I have the point 2, 4, and the point 2, -4. Pretty easy to see on my graph. So the point 2, 4, and the point 2, -4. Okay, so I use my equation. So x is 2 equals 1/8 times 4 squared. So 2 equals 1/8 times 16. 1/8 of 16 is 2. Well, that works. 2 equals 1/8 times -4 squared. So 2 equals 1/8 times 16, which is still 2 equals 2. So now that I've shown that both of those points satisfy the equation, I know that my equation works. So do you think all parabolas are similar? Explain why. Tell me in your own words. And don't copy that sentence down. What can we do to show parabolas are similar? How might you show this? Again, answer that question. All right, use the graphs below to answer questions 9 and 10. Suppose the unnamed red graph on the left coordinate plane is the graph of a function g. Describe g as a vertical scaling of graph f of x. That is, find the value of k so that g of x equals k times f of x. What is the value of k? Explain how you determined your answer. Well, just to look at it, it's kind of hard to see exactly what it is that they're talking about. But if we pick 2 points on the graph, if I pick when x is 2 on the blue graph, I have the point 2, 4. And this distance is 4. And if I go up to the red graph, I can see that this distance is 8. So my relationship from the blue parabola to the red parabola is going to be doubling the y value, because this would really just be y and this would be twice y. So that would mean that the red parabola has then y equals 2 times f of x. So that means that g of x is equal to 2 times f of x. So the value then of k is 2. Okay? Explain how we found our answer. So what's the value of k? So k would have to be 2. Explain how you determined your answer. Well, the graph is g is a horizontal scaling of the graph of f by a factor of 2. Therefore, g of x, hang on a second. All right, sorry about that. I think I said horizontal scaling instead of vertical. So when I was explaining, let me try that again. The graph of g is a vertical scaling of the graph of f by a factor of 2. Therefore, g of x equals 2 times f of x, we have written down. By comparing points on the graph of f to points on the graph of g, you can see that the y values on g are all twice the x values, twice the y values on f. So you could take any point. So here's a point, and on the blue graph, my y value is 1. On the red graph, it's 2. It's twice that. Okay? So you could say all y values of of g of x are twice the y values of f of x. Okay, and I believe 10 is on the next page, but yet the graph is on this page. Yep. So suppose the unnamed word graph on the right coordinate plane is the graph of function h. Describe h as a vertical scaling of the graph of y equals f of x. That is, find the value of k so that h of x equals k times f of x. Explain how you found your answer. Well, going back to that picture, let's take a point on the graph. When x is 2, we have this point here and this point here. My height is 2, my height is 4. So from here to here is y, and then from here to here would be half of y. So that would make the red equation y equals 1/2 f of x. So h of x is equal to 1/2 f of x. So k is equal to 1/2. Explain how you determined your answer. It's the same as before. The y values of h of x are 1/2 the y values of f of x. All right, so moving on. Suppose the unnamed function graphed in red on the left coordinate plane is g. Describe the horizontal, so here we go, I'm jumping ahead here. Horizontal scaling of the graph of y equals f of x. What is the value of the scale factor k? Explain how you determined your answer. Well, this time we have to go horizontally. So I know that we can go up to 4 here. It's a little bit easier to see. This distance here is 2. And then this distance from here to here is 4. And this is twice the 2, the 4 value. So if my blue graph is y equals f of x, that means that this is y equals f of 1/2 x. So the blue value is half of the red value. So the relationship there is just half of x. So we're still going to have our function g of x. This time it's going to be f of 1/2 x. K is actually going to be still 2. And we determine this because let's see here. For the same y value, so looking at g of x, so comparing points of f to g, you can see that for the same y values, the x values of G are all twice the x values of f. So if we go back up to the graph here, my y values are both 4, but my x value for the blue is 2, and my x value for the red is 4. So the x values of the red is twice that of the blue. Number 12, suppose the unnamed function graphed in red on the right coordinate plane is h. Describe h as a horizontal scaling of the graph of y equals f of x. What is the value of the scale factor of k? Explain how you determined your answer. So we're going to do the same idea. Let's go up to 4. This distance here is 1, and then this distance here is 2. So that one is half of 2. So what we're doing from the blue to the red, let's see here. Let's see here. Blue is my original, so going from the blue to the red, I'm taking half of it. So y for this equation would be equal to f of 2x. Because in order to get it to look like f of x, I have to double all the red values. So h of x is equal to f of 2x. So k is equal to 1/2. So again, when we compare f to g, or f to h, sorry, you can see that for the same y values, the x values on h are all half of the x values on f. Okay. Example, dilation at the origin. By the definition here, we have y equals k times f of 1 over kx. What this formula is allowing us to do is use both the vertical and the horizontal dilation. It takes care of both of them, so geometrically we get the parabola we're supposed to need. So we're going to let f of x equal x squared, and we're going to let k equal 2. Write a formula for the function g that results from dilating f at the origin by a factor of 1/2. So g of x is going to be equal to 2 times f of 1/2 x. And since f of x is equal to x squared, we will have g of x equals 2 times 1/2 x, the quantity squared. So when I do the math here, g of x will be 2 times 1/4 x squared, and 2 times the fourth is 1/2 x squared. And that is my equation. What would the results be for k equals 3, 4, or 5? What about k equals 1/2? Well, I will do k equals 3 for you, and the rest you will need to do. So if k is equal to 3, I'm going to go back up here, we would have g of x equals 3 times f of 1/3 x. And since the function is f of x equals x squared, we'll have 3 times 1/3 x quantity squared. So it'll be 3 times 1/9 x squared. 3 times a 9 is 1/3 x squared. So you try 4, 5.5. Thank you for being patient with me with this one. This was a long set of notes.